So good evening again, JBTeguihanon, Engineering and Chemistry tutorials. So we are going to study our topic for tonight is introduction. This is lecture one, energy or other energy sources. This is actually taken from the lecture of my former professor, TUP, Technological University of the Philippines, when I took my master. This was presented by and prepared by Engineer Dr. Emmanuel Ferrer, no? PhD in chemical engineering. So he was my professor in energy engineering uh, in my master as I took my energy engineering masters at TUP. Okay, so I will be using his material. Shout out for Dr. Ferrer. So this is the lecture, introduction, other energy sources. So as you can see, we have here the in the picture we have wind, we have hydro, we have geothermal, okay, we have solar, we have this is tidal wave, and probably this is I don't know what this is. Anyway, we will say it later. I forgot. Okay, so this was yeah, this is the lecturers. So we have here alternative energy source. Number one, we have solar. Okay, we have solar, and then after solar, we have wind. We have hydropower. We have tidal wave power. We have biomass. We have geothermal. Yeah, and then we go now for solar. So you see, this is an actual. This is not a what you call that concept, but this is an actual power plant somewhere. I think in I don't know where this, but this is an actual. Okay, this is a power plant. Okay, but power plant solar. So it has a tower. It has a tower here. Okay, and then all these during the time of the day, these solar reflect the power here of the sun, and then somehow it generates and heat the pipe, and that is actually being converted to a mechanical energy and then electrical energy. Okay, that's how it works. And then we have here types of solar power. We have an active. So in the active, you have a PU, you have hot water panel, and then you have piping system. You have an heat exchanger, and then you have a hot water storage here. Okay. And then you have a passive solar power, and this is how it looks. So what we have seen basically in the houses, that is passive type. Okay, wherein you have a solar panel, glazing panel, and then you will have a battery, and then the battery you store the energy and then you use it, okay, to drive your electric appliances. So that is passive type. Okay, and then active solar power is actually energy from sun is stored in a thermal mass. We need it. Heat from thermal mass is then pumped throughout the structure. Okay, that's what I said, like in here. Then active solar. This repair also to electrical generation using solar power. There are two ways to do this: photovoltaic cells and then use commercial electric facilities. And then you have also PV panels are on the roof. Okay, like this one. Then large scale solar electric site. This is very large. Okay, you can see the facilities inside. These are the panels, panels. So basically, the uh, the cons here is you need a lot of area, no? Land area. That's very obvious. So large scale solar electric site. These facilities use solar power to heat water to form steam. The steam goes to generate electricity just as in fossil fuel or nuclear electric plant. Okay, no release of air pollutants. So this is the pros of the solar electric set, large scale. No electricity generated at night. Of course, during the night, you cannot generate electricity, right? They do work or they do work on cloudy days. Yeah, that is the uh, active solar power. Now we go to passive solar power. So in passive, we have this work on the principle that hot air rises and cool air sink convection. So we have passive solar standard building configuration, direct heat gain of the sun, right? And then you have the solar heat air, and it moves through convection through the structure or to the thermal mass. This is the passive solar panel. You have a mass wall on the left side. Okay, and then the heat of the sun is going that way. Then you will have here this mass wall, and then you have here the trombo wall. Okay, so the solar power, the pros is this one. It's abundant because it's coming from the sunlight, no greenhouse gases, and a few other pollutants. It's simple, minimal repair needed. It's cheap over long term. Okay, that is pros. What is the cons? The cons is you need retrofitting if structure is not already designed as passive solar, has limitation during the night. Some location better sets at south rather than north facing slopes. Initial capital outlay can be high. So where in the Philippines we can have as a solar. Negros Island is considered to be one of the best locations for the solar farm. So in Negros, in here, this is the Negros. Okay, sack shape, yeah, island, right? So Negros Island is considered. So according to NRail study shows that the average of 5 to 5.5 kilowatt hour per square meter per day of power can be generated from Negros. Wow, that's good. So solar power in history. So we have history here. Okay, from 1767, and then we have 1876. Solar power furnace was used by Lavoisier to discover elements, particularly nitrogen. Then solar power and distillation used by French Foreign Legion and still used today. Okay, so we stop here because the next slide is about wind power. Thank you. Bye for now.